Okay, this is a video for Lesson 10 of Module 3, and it's titled Informal Proof of AA Criterion for Similarity. And our AA refers to angle. So our goal is going to be to show that if any two triangles have two equal corresponding angles, then they are similar. That's all we have to show, is that two of the angles are congruent. Okay, so back in Lesson 4, when we talked about the fundamental theorem of similarity, we drew diagrams like this on binder paper. And in this, you can see similar triangles, lots of places, but that triangle and then the larger one with the dilated points are similar. And in this diagram, you can see the equal angles of these triangles, and you can see the corresponding side lengths because one is a dilation of the other. So clearly this is a dilation situation, and so we know that those two triangles are similar because the dilation of one figure produces a similar figure. But today what we want to do is show that if I have two triangles, say I had that one and just brought them over here, if I could show that just two corresponding pairs of angles were equal in measure, I could show that those triangles were similar. Okay, so what we're going to need to show that they're similar is the other property of similar triangles, which you know, which is that the side lengths are proportional. So if we can show that given two equal angles, that the side lengths are proportional or in proportion, then we will have proved it. Okay, so let's talk about this. The other thing I want to mention too is we're going to call this the angle criterion for similarity. But think about any triangle. You could look at the one in my diagram. If I know two angles of a triangle, I know the third. So it could be called the angle, but we're just going to call it the angle because that's all that's necessary. There's no choice for the third angle once the first two are named. Okay? And that would be, of course, because the sum of the angles in a triangle have to add up to 180. Okay, here's an example I drew. I started with the bottom length. I made one longer than the other, so I've got 5.5, and these are all in centimeters on my drawing. 5.5 centimeters, the other is 7.8. And then I used my protractor to draw the angles and extended the lines up on these. And so I just extended it up, chose my angle, drew the same angle over here. Then I came over here, chose another angle, and chose another one, and the same one here, and created these two triangles. So I know these triangles have two equal angles. That's the only thing that I've done special. And so then I went and measured each of the sides. And I measured correct to the, as closely as I could to the nearest 1/10 of a centimeter. So I have 2.3 over 3.2 as corresponding sides, 4.2 and 6.0. And then the 5.5 and 7.8 are all corresponding sides. So to verify, so what we want to do is we want to actually verify that if two angles, verify the AA criterion. So if I have two triangles, which have two equal angles, I can know that they're similar. Okay, so if I can show that these side lengths are in proportion, I will have shown the angle criterion. And so what I've done, if I take 2.3 divided by 3.2 and check the ratio of this first corresponding side, get different angle. So 2.3 and 3.2. And when I do that, I get 0.6969 repeating, which is approximately 0.70. Okay, and then if I do the next one, so I want to do all three pairs. The next one would be the 5.5 and the 7.8. And for that one, I'm going to get 0.705, which is approximately 0.71. And then, so notice these similar ratios. And then the last pair of sides would be the ratio would be 4.2 to 6.0. And for that one, I get exactly 0.70. So you can see these ratios are all coming out equal. So my example here verified the angle criterion. We haven't proven it, but we have shown it to be true. So you could have very different triangles. If we were in class, we could see several different examples. You're going to do two, so you should prove to yourself that it wasn't a fluke that this happened, that, you know, that there actually is something going on, that if two angles in a triangle are equal, then the triangles are similar. So by drawing your own triangle, you're informally verifying the angle postulate, and maybe even after doing a couple examples, seeing why that it actually is true. But I'm just going to talk you through a simple proof, a little bit more formal than what we did. And we're going to use this diagram. And we have, in this diagram, we have two triangles that share one common vertex right here. So one vertex of these two triangles is the same. So I know that this angle here is the same for both triangles. So let me trace out my triangles I have. Well, I could just name them. I've got triangle A, B, C, and then I've got triangle A prime, B prime, C prime. Those angles share a common angle A. And I'm going to say that angle B, or angle, write it over here, the measure of angle A, B prime, C prime is equal to the measure of angle A, B, C. So that would be, this would be angle A prime, B prime, C prime, or A, B prime, C prime. And this is angle A, B, C. Okay, so we're told that these triangles share a point, and that these angles are equal. But we know, we could think of this line here, A, B prime, you know, that holds A and B prime as a transversal. And we know from our study with angles that if these two angles would be corresponding angles, and I know that if the corresponding angles are equal, that the lines that the transversal is cutting through, the lines are parallel. So I know that B prime, C prime is parallel to BC, because if B prime, C prime was not parallel to BC, then these two angles would have to be different. They could not be the same. So I know that those lines are parallel. So once I know those lines are parallel, I can talk about, I can define a scale factor, because what I'm working towards is to show that this is a dilation. If I know it's a dilation, then I know that I have similar triangles. So if I call my scale factor A prime B prime over A B, the dilated length over the original length, and I use, and we know that the length, and these are all lengths of segments here, and we know that the length of A C prime is equal to R, the same R right here, times the length of AC. Okay, and so what that's saying is that we have a dilation from center A with a scale factor of R, and that gives us that B prime, C prime, and BC are in proportion by our same scale factor, and therefore we have shown that all the sides are proportional for these two triangles, and we've shown that, well, we were given that the angles were the same, so we know that they're similar. Okay, but that was a special case, you say, where the vertex A was the same for both triangles. But what if we had a situation like this diagram that's at the top of the page here? If I have this situation, I have triangle A, B, C, and triangle A prime, B prime, C prime, and I've got A, these two angles being equal, okay? So I've got an angle here and this angle here, I'm given are equal. Well, if that's true, then I can just move this triangle right over and set it right here, and it would hit at some point B naught, we call this B naught and C naught. So I could just superimpose it over, and then the same proof that we just did would hold. Okay, so that's a slightly more formal proof of what you already verified by doing the measurements with the triangles that you drew. Okay, so now we're going to do a couple examples where we use this to argue whether two triangles are similar or not. So you can look at the bottom of the page here, and we have these two triangles, and they're labeled, this angle here is 80 degrees, this angle here is 25 in this triangle, and down here I've got a 25-degree angle and an 80-degree angle. And I'm asked, are the triangles below similar? Present an informal argument as to why they are, or why they are not. And so I could argue that they are similar, and I could write a statement such as triangle ABC is similar to triangle A prime, B prime, C prime. And the reason I know they are is because the measure of angle B is equal to the measure of angle B prime, and that's 80 degrees. And the measure, write it over here, the measure of angle C is equal to the measure of angle C prime is equal to 25 degrees. And because I know that they have two pairs of corresponding angles that are equal, I could say by the AA criterion, the triangles are similar. Okay, so here's another example you don't have in your book, but we're going to do a few that you do have in your notes. I'm given two triangles. Are the triangles shown below similar? Present an informal argument as to why they are or why they are not. So in this case, I have, whoops, let me get my pen. I have two angles noted in both triangles, and none of them are equal. So I would say that the triangles are not similar. Triangle ABC is not similar to triangle A prime, B prime, C prime. And the reason for that is there are not two corresponding angles that are congruent or that are equal in measure. So therefore, I can't possibly have a similar triangle situation. Okay, so here's another one. Are the triangles shown below similar? Present an informal argument as to why they are or why they are not. Okay, so in these two triangles, A, B, C, and A prime, B prime, C prime, I can see that angle C and C prime are congruent. So I have that the measure of angle C is equal to the measure of angle C prime. And then I have over here that A is 44 and B is 88. So I need to find out what the measure of this angle here is and the measure of this angle here. Because as they're labeled, I don't know that they have two congruent, but I can't say that they don't either. So if I use the fact that the angles of a triangle add up to 180, and I notice that 88 and 48 is 136, then I know that I can find angle A, and I can see that it's 44. So this angle here is 44 degrees, and I have my two pairs of corresponding angles that are equal in measure. And of course I have three as well, because once I have two, then the third one can only be one thing. Okay, so there you have it. So let's do some exercises and then you'll be ready to look at the problem set. Okay, so find exercises 3 through 5 in your class notes and work on those and then come back and check your work against mine. So go ahead and pause the video now and use the angle criterion for similar triangles to show whether these different pairs of triangles are similar to one another. Okay, so for exercise 3, we can see that we've got two pairs of corresponding angles that are congruent. Therefore, these are similar triangles. ABC is similar to A prime, B prime, C prime, because the measure of angle A is equal to the measure of angle A prime, and the measure of angle B is equal to the measure of angle B prime. Okay, in exercise 4, we're given angle A prime and A, both 31. We're given the second angle for A prime, B prime, C prime of 103, and a second angle for ABC of 85. So clearly the angles marked B and B prime are not equal. But in this case, because one angle is equal, I would want to check and find out what the measure of these angles are. So we'll use the triangle sum equality, and so 85 plus 31 is 116. So in this triangle ABC, this angle has to be 64 degrees. So I would not have three angles matching up. And in the case of the other triangle, I'd have 103 plus 31 is 144. And so angle C over there would have to be 36 degrees. So I don't have a situation where I have two triangles with two pairs of congruent angles. I only have one in this case. So these are not similar. Okay, let's look at exercise 5. Okay, let's do one last exercise. This is exercise 5. And you can check your work here. So in this one, we know for sure we have one equal angle measure. We have A and A prime being equal. And so I can see that the measure of angle A is equal to the measure of angle A prime. But we don't have the others labeled. We have a 48 degree and we have a 60 degree. So we need to find what the last one is to either verify that we have two that are equal or show that we don't have any that are equal. So again, we'll use that the angle measures add up to 180. So 72 and 60 is 132, which makes this angle 48 degrees. Okay, so now we have enough information. We've got two congruent angles, and so I can say here the measure of angle C is equal to the measure of angle C prime. I have two congruent angles, so I know that these are similar triangles. By the angle criterion. Okay, so once I've got the two similar triangles, two angle pairs that have equal measure, then I'm done. I know that the triangles are similar. Okay, and that is going to be really useful in geometry, in doing proofs and looking at diagrams and trying to analyze them. It's very helpful to find similar triangles like that. Okay, so you're ready for the exit ticket and the problem set, and so good luck.